We'll see how to rationalize the denominators. I'll explain to you 5 questions. I'll help you solving out these 5 questions. That is, see the first question, 3 by root 5. Remember that we are rationalizing the denominators, so we pick the denominator and we multiply it with the fraction, right? Root 5 by root 5. So 3 into root 5 will be 3 root 5 divided by root 5 into root 5 will be just 5. I have explained to you this before. So this is the answer, 3 root 5 by 5. Okay, we cannot make the conjugate, we cannot change the sign of the denominator. That's why we are just multiplying with root 5 and root 5 to the denominator. Right? Why cannot we change the sign? Because it's a radical, right? And you have learned the rules before, so it should not be very hard for you to understand. Let's see the second question. 2 root 3 by root 5, we have to multiply with the denominator. Okay, we multiply the fraction using the denominator, root 5 by root 5. So 2 is the real number, we cannot multiply it with the radical. We can multiply the radicals. 3 5s are 15 divided by root 5 into root 5 is 5. So this is the answer for the second question. I hope you have understood till here. And we can also write these terms as 3 by 2 into root 5, right? 3 by 5 root 5. And we can also write the second answer as 2 by 5 into root 15, or 2 by 5 root 15. Right? I hope you have understood it. Let's see the third question. And the third question is 1 divided by root 3 minus root 2. What we have to do here is we have to multiply with the conjugate of the denominator. Conjugate of the denominator will be root 3 plus root 2. Conjugate means to change the signs, right? So root 3 minus 2, the sign is, when we change the sign, it becomes root 3 plus 2. That is what we do to rationalize the denominator. We have multiplied the fraction with the conjugate of the denominator. Now let us simplify it further. 1 into root 3 plus root 2 will be, as the term is, root 3 plus root 2. Okay, root 3 plus root 2 divided by, now if you see the denominators of these two fractions, right, if you carefully see, it's much easier for you to understand. The first is in the form of a minus b, and the second denominator is in the form of a plus b, whose expression is a square minus b square. A square minus b square. So let us just write these two denominators in the form of a square minus b square. A square would be root 3 whole square, because root 3 resembles a, and b square will be root 2 whole square, because b resembles 2, or 2 is in the place of b. So we've got root 3 plus root 2 divided by, right, root 3 square resembles a square and root 2 square resembles b square. So looking at this term, I think you can understand that we can cancel the squares and square root. So that's what we will be doing, cancel the square and the square root. And when we cancel the square and the square root, we are left with 3 minus 2. And so the next step would be to simplify it further. Root 3 plus root 2 divided by 3 minus 2 is 1. So we can write the answer as root 3 plus root 2. So that is our answer. Let us see this fourth question. The fourth question. Right, keep practicing and it is much easier for you to get it. Fourth question is root 6 minus root 5 divided by root 6 plus root 5. Root 6 minus root 5 divided by root 6 plus root 5. What do we have to do? We have to multiply this fraction with the conjugate of the denominator. So what will be the conjugate of root 6 plus root 5? The conjugate will be root 6 minus root 5. So we're multiplying this fraction with the conjugate of the denominator, root 6 minus root 5. Right, now let's see the numerator first. Okay, let's solve the numerator of both the fractions. Root 6 minus root 5 into root 6 minus root 5. Now if you see here, this is in the form of a minus b into a minus b, which is a minus b whole square. Right, a minus b whole square. And I hope you remember the expansion of this. A minus b whole square is equal to a square minus 2ab plus b square. Right, so we will just use this expression and the expansion of this to solve it. Root 6 resembles a, so and root 5 resembles b. We'll write it in the form of a minus b whole square, root 6 minus root 5 whole square. And if you see the denominator of both of these terms, they are in the form of a plus b into a minus b, whose expression is a square minus b square. Okay, so we will write it in that form. Root 6 resembles a, which will be root 6 whole square, and root 5 resembles b, which will be root 5 whole square. Now you can see the numerator is in the form of a minus b whole square, and the denominator is in the form of a square minus b square. So let us simplify it more further. We'll use the expression a minus b whole square to solve the numerator. Remember that root 6 resembles a and root 5 resembles b. So a square, from the expansion, it will be root 6 whole square minus 2 into ab, that is root 6 into root 5, plus b square, which will be root 5 whole square. Right, I hope you have followed every step here. Divided by, we'll simplify the denominator here. The square and square root cancels for both the terms in the denominator, leaving it as 6 minus 5. Okay, 6 minus 5. Now we'll solve it further to get closer to the answer. Now you can see that the square and square root cancels, leaving it as 6. 2 is a real number, so we cannot multiply with the radicals, but we can multiply the radicals. Root 6 into root 5, and I'm sure you know the table of 6 or 5, so that will be root 30. 6 5s are 30, plus square and square root cancels of root 5 square, leaving it as 5, divided by, now 6 minus 5 is 1. We don't write the expression as by 1, right? So we'll simplify it much further. 6 plus 5 is 11 minus 2 root 30, and we will not be writing by 1. So here is the answer: 11 minus 2 root 30. 11 minus 2 root 30. Okay, now we'll see the last question. You can even pause, you can even take a break and see the last question. Okay, do not pressurize your head too much. Just go step by step and it's much easier to understand. Let us see the last question. Question number 5. What are we learning? We are learning to rationalize the denominators. So let us see this question. 2 root 5 plus 3 root 2 divided by 2 root 5 minus 3 root 2. You know what to do, right? We will multiply it with the conjugate of the denominator. And the conjugate of the denominator here will be 2 root 5 plus 3 root 2. That's what the conjugate of the denominator of this fraction will be. So we'll be multiplying this fraction with the conjugate. We'll multiply both the numerator and denominator with the conjugate of the denominator of the question. So the conjugate is 2 root 5 plus 3 root 2. That's what we are doing. We are multiplying both the numerator and the denominator with the conjugate. Now let's see the numerator and the denominator of these two fractions separately, and let's see in what form of expression these are. Let's see the numerator. 2 root 5 plus 3 root 2 into 2 root 5 plus 3 root 2. I am sure you are able to make it out that this is in the form of a plus b whole square. So we will write the numerator as 2 root 5 plus 3 root 2 whole square. And let's see the denominator. The denominator is in the form of a square minus b square. A minus b into a plus b. The expression of that is a square minus b square. So that's what we'll be writing in the denominator. 2 root 5 whole square, that resembles a, minus 3 root 2 whole square, that resembles b or b square. Let us simplify it further. Now the expression a plus b whole square, what is the expansion of this expression a plus b whole square? I'm sure you remember this. Two root 5 whole square plus, okay, let me just write it for you, a square plus 2ab plus b square, right? So we will just solve it using that expansion of the expression a plus b whole square. 2 into a, and in this term a is 2 root 5 and b is 3 root 2 plus b square, and b square is 3 root 2 whole square. Right, so we have simplified it using the expression and we'll just write down the denominator, right? 2 root 5 whole square minus 3 root 2 whole square. Let us solve it. I'll just show you in rough how to solve it. Now you see that square is for both the terms, 2 and root 5. So we'll separate it, 2 square into root 5 whole square. And here the square and square root cancels, leaving it as 2 square is 4 into 5. And when we multiply it, 4 5s are 20. So we've got the answer for 2 root 5 whole square as 20. Okay, we've got it as 20. Let's see the second term of the denominator, that is 3 root 2 whole square. I'll explain to you over here even how to solve the second term. I've explained in the previous videos also. So for those who are not able to, I'll explain for them once again. That square is for both 3 and root 2. So we segregate 3 and root 2. 3 square into root 2 whole square. Square and square root cancels, leaving it as 2. 3 square is 9 into 2. When we multiply it, we get it as 18. 9 2s are 18. So we got the value for second term of the denominator as 18. Okay, I'll just erase the rough part that I have done it, and we'll simplify it further. Let's solve the first term of the numerator, just like how I had made you understand how to solve the denominator. Let me also explain to you term by term to solve the numerator. 2 root 5 whole square, that square is for both the terms. 2 square into root 5 whole square, square and square root cancels, leaving it as 4 into 5, which is 20. So the value for 2 root 5 whole square is 20, plus there are 3 real numbers here. 2 2s are 4, 4 3s are 12, and we can only multiply real numbers and multiply radical numbers. So we have 2 radical numbers, root 5 and root 2. That is how we got it as root 10. 12 into root 10. Let me explain to you how to solve 3 root 2 whole square. That square is for both 3 and root 2. So we can write it as 3 square into root 2 whole square. The square and square root cancels, and we get it as 9 into 2. When you multiply it, we will get it as 18. So we got the value of 3 root 2 whole square as 18. I hope it is clear and understood till here. And let us solve the denominator now. 20 minus 18. So how much will be 20 minus 18? It is 2. Now we are close to the answer. Let's see the next step. Now if you see the numerator, which is a common multiplier for these 3 terms? The common multiplier for these 3 terms is 2. Okay, so we'll just write it, separating it with brackets. 2 10s are 20 plus 2 6 are 12, radical 10 plus 2 9s are 18, right? I hope it's understood. Divided by 2. So both the 2's will get cancelled. 2 1s are 2. We are left with the expression 10 plus 6 root 10 plus 9. We can add the real numbers. 10 plus 9, which is 19, plus 6 root 10. And this is the answer for the question. Okay, this is the solution. This is the answer for the question that we just did. So I hope you have understood it. Go back, go through it, and practice it. It's not that hard. Okay, just practice it. It's not hard. You just have to take some time to practice and do a little bit of maths. So there's a homework that I'm giving you. Rationalize the denominators of these three questions. Okay, do these three homework as you practice and learn.